let's work our way through the vocabulary this week. There are 14 words this time. Again, study. The last vocabulary was pretty painful for people. So let's talk about this. The fixed point about which a figure is enlarged or reduced. That's literally the center of dilation. That's that fixed point, and you saw that the first time. The center of dilation can be almost anywhere on the graph. It's from that you make it larger or smaller. The next one is the point about which a figure is rotated. Now, using the previous one, if this was center of dilation, because enlarge or reduction, this pretty much means dilation, and you can put that down there. Enlarge or reduction. This one, the point about which a figure is rotated, is the center of rotation. Most of the time, our center of rotation is going to be the origin, where the X and Y axis crosses. But you've seen, let's say your video game character is running right across the screen and he hits an apple and now he spins in a circle. That center of rotation was on him or on the apple. And you've seen those kind of video games where he just kind of spins around in a circle. That's a center of rotation. All right, number 3. A plane formed by the intersection of a horizontal number line called the x-axis and a vertical number line called the y-axis. We've been doing this the whole time. We just didn't call it a coordinate plane. A coordinate plane. It's an x and y axis. And I will tell you, as you move forward, they're going to throw in a z. So x is left and right, y is up and down, and z is forward and back. But you don't have to know that for a couple of years. But video games would be utterly boring if all we did was move along the x and y axis. There'd be no fun to them at all. So a coordinate plane is what we call that, and that really just looks like the x and y. So I've got an x-axis and a y-axis. That's a coordinate plane. Make sure you draw your coordinate plane. Bryson.
I think I have a piece of tree.
Okay. So the last one, or the next one, says a transformation that changes the size of an object, but not the shape. We talked about the size. What are we talking about? Dilation. Now think about that. You guys use the term dilation frequently. In fact, Bryson just used it. He talked about his eye. The eye dilates. The pupil dilates. In dark light, it gets real big, and if you've ever had a real good time, shine a flashlight at somebody's eyes and then suddenly pull it away and their eye go, and the pupil will enlarge because it's really fun.
Like you could tell if you have a concussion?
Right, because their eyes dilate. So dilation is commonly used in the eye because the eye, that eye doesn't change shape. It just changes how big or small it is.
So everything just depends on your pupil?
Your pupils, your eyes are a pretty amazing device. Huh?
I heard your eyes tell a lot.
Yeah. Okay. So this is the dilation with a scale factor greater than 1 or greater than 1. Now we're going to talk about scale. We're going to talk about scale factor. That means how big it is. I like modeling. I used to do a lot of car models. The scale factor is less than 1 because greater than 1 means it gets bigger. If you were to build a model car and the scale factor was like 2, that means it would be twice as big as a normal car. So a scale factor greater than 1 is called an enlargement. Enlarge. Yeah. So an enlargement is a scale factor greater than 1. It gets bigger. A figure resulting from a transformation. Now, this is one, and if you paid attention to the backboard today, it said you'll use transformations and dilations to create images. A figure resulting from a transformation is called an image. And I always thought the definitions were a little weird, and you'll see why in a moment. But the image is what you get after you do whatever. Does that make sense? That's your final image. You did something to it, and then there's the image. Before that is what we call a pre-image. We'll get to that in a moment. All right, number 7. A line that a figure is flipped across to create a mirror image of the original figure. It's a line, right? It's a line of reflection because you flipped it across, right? You flipped it across the line. There's my line of reflection. I flipped it across that x-axis. I flipped it, just like pancakes.
Is that why you sing the pancake song?
No, I just do that anyway, because I have issues. Okay. We talked about this before. The image is what comes after. The pre-image is what comes before. It's a pre-image. Now, the pre-image, if you were to label a pre-image, you would label all the points like A, B, and C. If you go, the image will have the same points, but it'll be A apostrophe, B apostrophe, and C apostrophe. And that's how you'll know it's an image or a pre-image. The image always has the apostrophe after. Does that make sense?
Oh, this is where we stopped in school.
So, if you see that apostrophe, you know you're looking at an image.
Why?
That's the way the notation is done. Somebody before you, when you get older and you come up with something cool and new in math, you kind of get to set the rules. And if you find something really cool, other students will be hating you forever and they'll just not know why because you called it this. Okay? Number 9. A dilation with a scale factor between 0 and 1. If greater than 1 was enlargement, what do we call the opposite of enlargement? A reduction. Now, why can't the reduction get less than 0? Why can't you reduce something to less than 0? It's gone. Yeah, 0 is it. And you can't really reduce something to 0. It's not there at that point. But you could reduce something to 0.000001. That's why a lot of times you'll have models that are reductions like 1 to 25th. The scale factor is 1 inch on the model equals 25 inches on the real thing. Or 1 unit. So number 10, a transformation of figure that flips the figure across the line. It's flipping, which means we're reflecting. It's a reflection. We're flipping it across the line. The same thing happens when you look in the mirror. If you've never noticed, everything's backwards in a mirror, right? And if you've never noticed that, hold up some writing to the mirror and notice that it's all written backwards. That way you'll feel smarter.
Anybody say anything?
Number 11, a transformation in which a figure is turned around a point. So there's a point and the figure goes around the point. We call that a rotation. And we normally do that by degrees. We'll say a rotation of 90 degrees clockwise. Or 90 degrees counterclockwise.
Is there not like abbreviation for counterclockwise?
CC.
Oh.
CCW.
That's what I thought.
We could also do a 180 degree rotation, which is completely around the back. If I do a 180 rotation, is there another way a lot of times to accomplish that, depending on the shape? A reflection. Okay. You'll see that. If the images are equilateral, means equal sides, then it'll do it. So the ratio used to enlarge or reduce similar figures. We talked about that before. It's called the scale factor. One of the things we'll be doing after the STAR test is creating some stuff using scale factor.
Skill or scale?
Scale.
That's what I thought that was. But
We'll be doing some modeling using scale factors.
What are scale factors?
The scale factor is a reduction or enlargement. Remember, an enlargement makes it greater than 1. If I want to make it bigger, I enlarge it by so much, maybe twice as large, or 3 times as large, or 4 times as large.
Yeah, that's what I thought this was.
Is it easy?
It can be. And a reduction makes something smaller.
That's a new.
So, 13. A change in the position or orientation of a figure. That's a translation. Nope, sorry. That's a transformation. I'm ahead of myself. Now, a transformation includes everything like translations, rotations, reflections, dilations. They're all transformations. You're doing something to a figure. You're taking a pre-image and creating a new image from it. And if you think about that, video games would be boring if the character just sat on the screen right in front of you and never moved left or right, up or down.
There is a game like that.
When I started, there were a lot of games like that. You just you typed it, but it's not very exciting. So the last one is a movement or a slide of a figure along a straight line, and that's a translation.
I knew it.
If you want to translate, you slide, and it's a good dance move too. You can throw it in there with the positive slope, negative slope, and put a little translation. Slide, translation to the left, translation to the right.
Yeah, we're not gonna
Clap 3 times. Translation back. Translation back. Hop 3 times.
You weren't a lady fan, were you?
Actually, I did quite well, but I wasn't what you thought.
Are you gonna do that to everyone?
Wait, so were
What?
you?
What you did?
Did it stick it in your head?
Yeah.
Did it stick it in your head?
Kinda, yeah.
Cool. You got a translation. You know that dance already. You knew exactly what I was talking about, right?
Yeah.
So translation is moving it. So we're going to be talking about the whole thing of transforming an image or moving it around. It is one of the most common uses of math. You don't even think about it. Does that make sense? You're staring at your cell phone. You're watching transformation.